going to be about inverse functions. The inverse of a relation is a set of ordered pairs obtained by switching the input with the output of each ordered pair in the original relation. The domain of the original is the range of the inverse and vice versa. If you'll look at our example, the f of x is equal to 5x plus 2, while the inverse is equal to x minus 2 over 5. Okay, because their inputs and outputs are switched. For instance, if I put in a 4 for the x in the original one, then I will get out a 22. If I put in 22 into the inverse, then I will receive 4 for the output. Okay, we can take another look at inverse relationships with tables and graphs. Notice the original graph is a parabola and the table is next to it. For the inverse, I would just switch the x and the y values and then replot the points, and I would get a parabola that is on its side. And although transformed, the graphs are identical. Remember that for inverses, the line of symmetry is y equals x. Okay. So for the given coordinates on f of x, we're going to find the inverse coordinates. So for the first one, we would just swap them and we'd have 4, negative 2. Why don't you try the next one? That's right, it is 7, 4. The 0, 11 would become 11, 0. Why don't you try the next one? That's right, it's negative 8, negative 3. And of course, 10, 10 is still going to be 10, 10. Remember, inverse is expressed by f to the exponent of negative 1 x. Okay? When we look at inverse mapping, notice that we start in the y column and draw to the x column. These are not pink lines, these are blue and red lines. But again, you're going from the y column to the x column. Okay, to find the inverse of a function, we're going to switch the x and y of the function whose inverse you desire. Then you solve for y to get the inverse function. You have to check the domains and ranges of your inverse and original function matchup. So to find the inverse of the following function, d of x is equal to 4 square root of x plus 3. So we need to remember the d of x we can express as a y. Okay, once we do that, we can then switch the x and the y. We will solve for y. So we're going to subtract 3 from both sides. So we get x minus 3 is equal to 4 square root of y. Divide by 4. Then in order to get rid of the square root sign, we have to square both sides. If we graph these, notice that our original function was actually only half the parabola. So a full parabola is too much, and so thus we are going to restrict the domain to x greater than or equal to 3. All right, let's try these examples. Okay, we're going to change the f of x to y, so we get y equals 15x minus 1. We're then going to switch the x and the y. So I get x is equal to 15y minus 1, and we add 1 to both sides in order to start solving for y. So x plus 1 equals 15y, divide by 15, and now we get that x plus 1 over 15 is y, and that y represents the inverse of the function. Okay? Let's take a look at the next one. Again, we're going to change the f of x to y, so we get y equals 1/3 x plus 7. We're going to switch the x and the y, and then we are going to solve for y. So we're going to subtract 7 from both sides. We must multiply by 3. We will distribute the 3 through the parentheses, so we get 3x minus 21 equals y. You're going to try this one on your own. All right, let's look and see what happens when we have an exponent or a square root. Again, we're going to change the f of x to y. So y is equal to x minus 2 squared. We're going to switch the x and the y. So x is equal to y minus 2 squared. Then we're going to solve for y. Okay? In order to do this, we have to make sure must square root each side. Okay? When I square root each side, this gets rid of the square with the y minus 2, so it's by itself. So I get a square root equals to y minus 2. I add 2 to each side, and that solves it. And again, remember that the y really is the inverse. Okay, let's take a look at our last example. Again, we're going to change the f of x to y, so y is equal to the square root of x minus 4. We're going to switch the x and the y. Okay, so now x is equal to square root of y minus 4. I'm going to solve for y. We're going to square each side. Okay, so we get x squared is equal to y minus 4, and then we just have to add 4 to each side. So we would get x plus 4 is equal to y. All right, for something to be a one-to-one function, for a function to have an inverse function, it has to be a one-to-one function. Okay? So the horizontal line test. If a horizontal line intersects a curve more than once, its inverse is not a function. Okay? I'm giving these letters. Use the horizontal line test to decide which graphs have an inverse that make it a function. So if you'll please answer which ones are functions by the horizontal line test. That's right. The parabola that's on its side by the horizontal line test, its inverse is a function, and a parabola is a function. The other one is a function, and it's a cubic function. All right, we are going to graph the following points. Okay, so please notice that we're at -2, 4, at 0, 1, and then at 2, 6. Okay, the inverse points, we just have to switch out our x and y's, and notice that we have an inverse line. One of the important thing about inverses is that they are going to cross and at this diagonal line, and this diagonal line is the line of symmetry, which is y is equal to x. Okay, so that's important about inverse functions. They will always join each other on y equals x, the line of symmetry. All right, thank you for participating, and that is the end.